Alright, so we're doing exercise 9F, which is all about conditional probability, and we're looking at question 7, which tells us that 100 people were questioned and classified according to sex and whether or not they think private individuals should be allowed to carry guns. The results are shown in the table. Do you think private individuals should be allowed to carry guns? So as you can see here, we surveyed 100 people, 60 of which were male, 40 of which were female. 65 people said yes and 35 people said no. We can then look at the intersection of the people who were male and said yes, and that's 35. The intersection of the people who were female and said yes was 30. And so too, we have 25 males who said no and 10 females who said no. So let's now, before we jump into the question itself, let's ask ourselves the question: if we had these 100 people lined up before us, what's the probability of us randomly selecting someone who is going to say yes to our question? Well, we know it's going to be out of 100 people because that's how many people are standing before us. And we know that the total amount of people who said yes was 65. So it's going to be 65 out of 100 if we were to randomly select one of these people and the probability of them saying yes. Let's now go to the question at hand, which says one person is selected at random from these 100. Given that the selected person is male, what is the probability that they think private individuals should be allowed to carry guns? So now we're going to find out what's the probability of saying yes given they are a male. Well, if we know already that they are a male, are we going to say it's out of 100? No, rather we're going to say it's out of 60. So too, for our numerator, are we going to say that the total amount of people who said yes was 65? Of course not, because this 65 was the addition of the males who said yes and the females who said yes. But these females aren't going to be valuable or relevant for trying to figuring out the probability of the males who said yes. So rather, I'm going to take this. I'm going to take my 35, the males who said yes. And now I can simplify this. 35 divided by 5 is 7. And 60 divided by 5 is 12. So that's going to be my answer. So if you look at the back of the book, your answer is going to be 7 on 12. And let's just stop and think about this for a second. What we did is we found where yes and male had an intersection point, and we took it all over the males. So this right here, this 35 is the intersection of yes and male, and then we divided that by the total amount of males. Before we move on, I want to talk about another way we could have approached this question. So to find the probability of yes given that they are male, we could have also done this. We could have found the probability of yes intersection of male over the probability of a male. So what's the probability of the intersection of yes and a male? Well, it's going to be 35 over 100. So 35 over 100. And what's the probability of getting a male? Well, the probability of getting a male is going to be 60 out of 100. So it would be 60 out of 100. And hopefully you know how to manipulate fractions when I'm dividing two by each other. What you're going to do is you're going to go 35 times this 100, which is going to leave us with 35, 2 zeros on the end. And then we're going to go 60 times this 100, which is going to give us 60 with 2 zeros on the end. Then we can simplify this by getting rid of these zeros. So what I'm going to have is 35 over 60. And hopefully what you can see there is that is the same as this. So therefore, even by going through a different method dealing with the probabilities, we're still going to end up with 7 out of 12. And this is important when we now come to this. So here, this is taken from the textbook, and it's a general principle that is always true, which is that the conditional probability of event A, given that event B has already occurred, is given by the probability of A given B, the probability of the intersection of A and B divided by the probability of B, if the probability of B does not equal 0. So hopefully you have a deeper appreciation for this general principle, and you've been able to successfully answer question 7. Hopefully this was helpful.